Let's take a look at this example. Again, please notice that a, my unknown, is the part of this radical, and a is also the part of the radical on the right side of the equal sign. First, we're supposed to eliminate the radical sign. Remember, anytime there is no number over here, there is always invisible 2. That's why I have to raise both sides, because I have square roots on both sides, to the second power. Why to the second? Because this is the second order radical. This exponent is going to eliminate this sign, and this exponent is going to eliminate this sign. My equation is going to look like this right now. A over 3 equals 2a minus 4. I have to find a. I have a on both sides of the equation. One of them is part of the fraction. First, I'm going to eliminate the fraction. How I can eliminate the fraction? Simply by multiplying both sides equation by 3. Okay, multiply both sides equation by 3. 3 and 3 will cancel out. And I have a equals 2a minus 4 times 3. I have one of the a's inside of the parentheses. I have to eliminate these parentheses. I can eliminate these parentheses by distributing this 3 into parentheses. Distributing means multiply every single term from the parentheses by 3. I have a equals 3 times 2a gives me 6a. 3 times negative 4 is negative 12. Because I have positive 6 and positive 6 is greater than 1, in order to avoid creating extra negative numbers, I'm going to take this a and move to right side, and this negative 12, because there is no a next to 12, I'm going to move to the left. I'm going to end up with 12 equals 6a minus a. I have 12 equals 6 minus 1 is 5. 5a, remember, anytime there is no number on the front of the variable, there is always invisible 1. 6 minus 1 is equal 5. Next, remember, we have to find a. In order to find a, we have to eliminate the multiplication. Okay, 5 is multiplied to a. I will have to remove 5, okay, by dividing both sides equation by 5. Remember, whatever you did on one side of the equation, you have to do also on the other side. 5 and 5 will cancel out, and I'm going to have a equals 12 over 5. Remember, anytime we're moving everything from right side to left and everything from left to right, we don't change the signs. Okay, so we can say this is my solution. But let's verify if this is correct. I'm going to replace every a in my original equation by fraction 12 over 5. I have square root 12 over 5, and it's over 3, is equal square root 2 times 12 over 5 minus 4. Because I have fraction in the numerator, I'm going to convert denominator also to fraction. Okay? Now, remember, anytime we divide fractions, we have to copy first fraction, and division sign we have to change to the multiplication, and we have to find the reciprocal of the second fraction, which is 1 over 3, equals Now we have to perform the multiplication. 2 times 12 is 24. That's why I'm going to write over here 24 over 5 minus, and I'm going to convert 4 to fraction because I have fraction over here, 4 over 1. Next, I have to check if I can reduce anything from this product. Remember, anytime we have multiplication of two fractions, we're supposed to check first if we can reduce any denominator with any numerator. I have 12 and 3. Both of these numbers are divisible by 3. I'm going to divide them by 3. And I have square root 4 over 5 times 1 over 1 equals square root. If I want to subtract these two fractions, I have to find a common denominator. The common denominator for 5 and 1 is 5. So I have 24 over 5 minus 5. Okay, 1 times 5 is 5. And if I multiply the denominator by 5, I have to also multiply numerator by 5. 4 times 5 is 20. I have square root 4 over 5 equals square root 24 minus 20 is 4, and denominator stay the same, 4 over 5. As you can see, left side is equal to the right side. That's why A equals 12 over 5 is the solution to my problem. Let's take a look at this example. Again, we have square roots on both sides of the equation. Okay, whole left side is under the radical sign and whole right side is also under the radical sign. That's why I can square both sides of the equation. Remember, I have to square it in order to remove the radical signs. So this square is going to eliminate this radical sign, and this square is going to eliminate this radical sign. And I have y plus 4 equals 5y plus 4. Now, please take a look. We have y on the left side and I have 5y on the right side. I have positive 5y. In order to avoid creating negative terms, I'm going to move this y to right side and this 4 to the left side. I move this 4 out from this side because this 4 has no y next to itself. That's why I have 4 minus 4 equals 5y minus y. 4 minus 4 is equal 0. 5y minus y is equal 4y. I have 0 equals 4y. Anytime I want to find y, I have to divide both sides equation by whatever is multiplied to my variable, in this case 2y. I have to divide both sides equation by 4. 4 and 4 will cancel out. 0 divided by 4 is equal 0. So I say that y is equal 0. Let's check if my answer is correct. I'm going to replace every y in my equation by 0. I have square root 0 plus 4 has to be equal to square root 5 times 0 plus 4. 0 plus 4 is 4, so square root of 4 equals square root 5 times 0 is 0 plus 4 is 4. You can go further. Square root of 4 is 2 and square root of 4 is 2. Left side is equal to the right side. That's why y equals 0 is the proper solution to my problem.